Okay, today we're going to do a few examples of solving radical equations. So radical just means that there's a root involved. Um, it's pretty similar to solving normal linear equations or normal quadratic equations. You just have a few extra steps to do, and then you um, pretty much your goal is just to get rid of your roots, and after that you can solve like normal. So just really quick before I get into the examples, pretty much what's going to end up happening is you're going to have your x and it's going to be underneath a root of some sort. So it could be a squared root. The root without a 2 is always a squared root. Or a cube root, or maybe a seventh root. It doesn't really matter what this number is. And since we're trying to solve for x, we need to get this x out from underneath this root. So pretty much how we do that is in the square root case, we square both sides. So this expression here is going to simplify to just x. In the cube root case, we just cube this. So this expression here simplifies to just x. And you can probably tell that whatever number you have, it's you just have to take a seventh root to the seventh power, or the nth root to the nth power, and you'll just end up with x. So we'll see how this plays out when we're solving these equations. So we'll do this nice simple example first, and hopefully it'll make sense. So I'm just going to rewrite this here in the middle. So here we have x plus 5 underneath a square root. And in order to solve for x, we need to get rid of this square root. So what I'm going to do is I'm going to square this in order to get rid of that root. And since this is an equation, what I do to this side also has to happen to this side. So this side is also going to end up getting squared. So what we're left with is x plus 5 equals 2 squared. So here the square root and the square cancel, and we're just left with x plus 5, and then over here we just have 2 squared. So we can do a little bit more simplification. X plus 5 equals 2 squared, which is 4, and then we'll subtract 5 from both sides. So x equals 4 minus 5, or x equals -1. One thing that's important is that you always plug your answers back in to the original equation. So we want to take this -1 value and we want to plug it in up here just to make sure that it works. So here we have, I'm just going to rewrite the original equation. We have the square root of x plus 5 equals 2, and we said here that x equals -1. So I'm just going to put in a -1 for x in my equation here, and I'm going to see if this is true. Well, -1 plus 5 is 4, so this turns into the square root of 4, and sure enough the square root of 4 is 2, so we end up with 2 equals 2. So our answer works, and this is checked, and that's our solution right here. Plugging these answers back in becomes important when you're dealing with square root functions and radical functions and rational functions, just because you can have some problems where you plug in a value for x and it ends up not working. And we'll get into that more later. Let's do another example. This example is a little more difficult. And then in another video we'll work on some more examples of this that are even more challenging. So here we have two x's, and one of them is trapped under a root and the other is not. So I'm going to follow the same procedure. I'm just going to square both sides of this root just so that we can get rid of this square root here. So I square this and then I also square this. So that simplifies down to x squared equals x plus 6. And now we successfully got rid of our root, but we have this x squared term. So pretty much what that means is we have a quadratic equation. So we just have to solve this like it's a normal quadratic equation. So if I subtract x and subtract 6, I'm going to end up with x squared minus x minus 6 equals 0. So here what I did was I just moved both of these terms over to the other side. And now we want to just try to factor this quadratic. So something that multiplies to -6 and adds to -1, it's going to be -3 and +2. So x minus 3 times x plus 2 equals 0. So if we end up foiling this out, you can check that we get this quadratic right here. So now we just need to set each of these terms individually equal to 0. So x minus 3 equals 0 and x plus 2 equals 0. So our solution here is going to be x equals -2 and x equals +3. So there's our two solutions, and now we just have to make sure that we plug both of these in. So I'm going to take this equation up here and I'm going to plug in +3 for all my x's. So we get 3 equals the square root of 3 plus 6. So that's our first check. And then our second one is plugging in a -2. So I get -2 equals the square root of -2. Sorry, that's a -2 plus 6. So let's simplify this first one. 3 equals 3 plus 6 is 9, the square root of 9. And this one's going to work out. The square root of 9 is 3. So this answer is checked, and this is going to be one of our answers. Now let's look at this one. We have -2 equals square root. Well, -2 plus 6 gives us a +4. And the square root of +4 is 2. So here you can see that we have -2 equals 2. So that actually doesn't work. We're off by a negative. So this is actually not going to be an answer. So this equation, even though we factored it down and solved for two solutions, this equation only has one answer. So that is this answer here. So just make sure to plug those guys in.